Assalamualaikum and hi everyone. Okay, in this lesson, you will learn how to solve non-parametric surface. For non-parametric surface, we have circle, we have ellipse, we have paraboloid, and this one is tetrahedron, and this one is cuboid. Okay, let's look at some examples of non-parametric surface. Okay, if the surface is given by this equation, okay, z equal to some constant, okay, minus x minus y, or the surface is write as z plus x plus y. So x and y here is move in front. Then we have plus positive x and y equal to some constant in the first octant. Okay, this surface is a tetrahedron, where this value here is the xyz intercept. So for this example, the intercept is 4. When you draw figure, okay, the intercept is 4. This is 4. Okay, if the surface is given by this equation, okay, z equal to 3 minus x minus y. So the x, y, z intercept is 3. Okay, if this surface is given by z equal to 16 minus x square minus y square, or when you move in front, you will get z plus xy plus y square equal to some constant. So this is referred to paraboloid. Okay, the surface is paraboloid. Okay, so remember, okay, for sphere, we have z square plus x square plus y square equal to some constant. But for paraboloid, we have z, okay, with x square and y square. Okay, we have two types of paraboloid. The first one is when the paraboloid is facing downward. Okay, and second is when the paraboloid is facing up. Okay, when x square and y square is negative x square and negative y square, then the paraboloid is facing down, like this. Okay, and the values here, okay, if you have values at the back, okay, refer to the z intercept. Here we have z intercept 0, so we have 0 here. For this example, z equal to negative x square minus negative y square plus 4. So z intercept is 4. Okay, so if the parabola is facing up, when we have positive x square and a positive y square. For this example, we have 0 intercept 0 here, then the parabola is intercept x z equal to 0. For this example, we have negative 2 at the back, so the intercept is negative 2, and here positive 2. So we have this graph. Okay, so remember, for non-parametric surface, make sure you write z in front, z equal to something. Okay, here is because it is more easier to identify the type of surface. Okay, these are the steps to solve surface integral for non-parametric surface. Okay, the surface integral, okay, for non-parametric surface is given by this formula, where you must do double integration in R region, and the vector of f, okay, dot product with the unit normal of the surface to dA. dA is the two-dimensional of the surface. Okay, the first step is to find unit normal vector of the surface. So you must refer table. Okay, the unit normal, the n, okay, the formula of n is depends on the form of z. if z equal to z is given by this form, okay, you must refer this table, and then and so on. And you must refer also the orientation. If the orientation is positive or upward orientation, okay, you must refer this, the first row. But if the orientation is negative or downward, okay, you must refer this row. Next, calculate f dot n. Okay, here. After you calculate n, after you get n, unit normal, then calculate dot product with the vector. Okay, at this step, you must make sure that the variables are not more than 2. That step, if the surface is paraboloid, you must convert the equation, or this equation f dot n, to polar coordinate. Okay, but for others, okay, convert the surface to 2. Sorry, here is 2 dimension. 2D. Step number 4. Okay, determine the limit based on your figure or your surface. And last one, okay, solve the integration. Okay, look at this example. Determine the flux across the surface. Okay, flux refer to, flux of the surface refer to surface integral. Okay, across the surface, z equal to 4 minus x minus y in the first octet. Okay, refer to examples here. So, z equal to 4 minus x minus y, refer to tetrahedron. Given that f with downward orientation. So, draw this graph for tetrahedron where we have the xy intercept is 4. So 4. Okay, this is a tetrahedron. A tetrahedron is a non-parametric surface. So you must calculate surface integral by using this formula. Okay, the first step is to find n, okay, unit normal vector, using the table. Okay, we have z equal to 4 minus x minus y. So z in the form of x and y. So refer this column. And we have downward orientation. Okay, downward orientation is negative orientation. So n is given by this formula. Z over x, okay, z over y, and negative 1. Okay, you differentiate z to x here, and you will get negative 1, z to y, negative 1, and negative 1. So unit normal vector is given by this the vector. Negative 1, and negative 1. Okay, step number 2, calculate dot product of f and n. So f equal to 0, negative 2, negative 1. Okay, dot product with n. N is negative 1, and negative 1. Okay, dot product 0 multiplied with negative 1 is 0. Negative 2 multiplied with negative 1 is 2. So 0 plus 2. Negative 1 multiplied with negative 1 is 1. So plus 1 equal to 3. So the dot product of n, f and n is equal to 3. Okay, step number 3. Okay, convert from a 3-dimensional to 2-dimensional. So this is the 3-dimensional figures or graph. So you convert to 2-dimensional. So we just consider this area only. area at xy axis, because we want to find flux in the first octant. Okay, flux is how much fluid flowing through the surface. Okay, imagine fluid flowing through this surface. Okay, the fluid is actually passing through this area. Okay, this xy area. That's why we convert to 3D to 3D to 2D. So then determine the limit. Write down the equation to find R F dot N dA, okay, equal to F dot N is 3, okay, 3 dA. dA is refer to two-dimensional, so dA here is dy dx. So we want to integrate to 3 to dy and dx. Okay, how to determine the limit? Okay, first look at the limit for y. This is limit for y, and this is the limit for x. Okay. First, to determine the limit for y, okay, put the limit in the form of function of x. Okay, so if you consider integration of 3 dx dy, okay, then this limit you must put function of y. Okay, if we consider this one, this integration of dy and dx, okay, we have this figure, okay, in xy axis. So we want to consider the limit for y. So y start from 0. Okay, this graph. Okay, y start from 0 to this line. This line to y equal to 4 minus x. Okay, because our surface is z equal to 4 minus x minus y. Okay, this xy axis, z equal to 0. So 4 minus x minus y, then you rearrange y in front of y, so y equal to 4 minus x. Okay, so this line is referred to y equal to 4 minus x. So actually we want the limit is from 0 to this line. This line is given by y equal to, this one is y equal to 0, and after up to this line is 4 minus x. So that's why our limit is from 0 to 4 minus x. Okay, next, okay, this one you must put number. So x is from 0, x equal to 0 until 4. Okay, because the radius, okay, or the intercept is 4. So 0 to 4. Number 5, solve this integration. Okay, solve this integration. Okay, we have 0 to 4 minus x, 0 to 3, 0 to 4, 3 dy dx. Okay, first solve for y. We have 3y. Substitute. Okay, 4 minus x minus 0, you get 3. 4 minus x minus 0 is 0. Okay, dx, and then you integrate, get 12 minus 3x, then integrate to x. 12x minus 3x squared over 2. Okay, from 0 to 4. Okay, substitute 4 here and minus 0. Okay, you will get integration equal to 24. Okay, so the flux that flow through the surface equal to 24. Okay, let's look at example 4. Evaluate the surface integral over a vector field f across the surface z equal to 16 minus x squared minus y squared above z equal to 0. So we have this surface. Okay, compare with this one. So we see that this is paraboloid. Okay, and we have negative, right? Negative. So the parabola is pointing downward. Okay, where the z-intercept is 16. So here is 16. Okay, how we get 4 here? So x y axis, this axis, we have circle. So when z equal to 0, so 16 minus x squared minus y squared equal to 0. So we have x squared plus y squared equal to 16. So this is the equation for circle. So we have, this is r radius for circle, r square. So r equal to square root 16, 4. So the radius is 4. And we have above z equal to 0. Okay, above z equal to 0, so we consider this part only when z greater than 0. Okay, since paraboloid, this is surface for paraboloid, is non-parametric surface. Okay, to find, the first step is to find unit normal vector. Okay, unit normal vector, please look at the table, and we have z equal to 16 minus x squared minus y squared. So z in the form of x and y. So look at this column, and the orientation is, we have positive pointing normal. So positive orientation. Okay, so the n equal to negative z over x minus z over y and 1. Okay, differentiate z to x, we get here, we get negative 2x. So negative, we get 2x, negative 2x, negative 2y and 1. Simplify. Okay, so this is the unit normal vector for this surface. Okay, step number 2 is to calculate dot product with vector f. So this is vector f here, x, y and z. Okay, step number 2 equal to x, y, z dot product with n. Our n is 2x, 2y and 1. Okay, do dot product, multiply, we get 2x squared plus 2y squared plus z. Okay, so for step number 2, you must check, okay, the variables is maximum is 2, but here we have x, y and z. So z here, you must change to x and y. So we know that z from the surface, z equal to 16 minus x squared minus y squared. We substitute z here. Then we have 2x squared plus 2y squared plus z is 16 minus x squared minus y squared. Okay, and then you simplify. We get x squared plus y squared plus 16. Okay, this is dot product of n and also vector f. Okay, step number 3. Okay, since the surface is paraboloid, okay, remember our step, paraboloid, then you must change to polar coordinate. F dot n equal to x square plus y square plus 16. Convert this coordinate to polar. So we have x square is r cos theta. So r cos theta square plus r sin theta square plus 16. Okay, simplify, we get r square cos square plus r square sin square theta plus 16. Okay, factorize. Okay, this one cos square plus sin square equal to 1. Then we get r square plus 16. Okay, then you determine the limit. Okay, substitute f dot n in the formula and determine the limit. We have r square plus 16 here, dA here, the area is with right now is the surface of circle. So dA r dr d theta. Okay, here for this example, for circle, okay, you cannot substitute r with the radius. Here radius r equal to 4, right? So okay, you cannot substitute r equal to 4 because we want to determine, okay, because we want to integrate to r here, dr. Then simplify, we have r power of 3 plus 16r dr d theta. Okay, determine the limit. So we have for r is from 0 to 4, 0 to 4. Theta is theta from x to here, the angle and at xy axis, so 0 to 2 pi. Okay, then integrate. We get integrate to r. Okay, after that you integrate to theta. Okay, and the final answer will be 384 pi. Remember, for non-parametric surface, at this step, when you do dot product, f dot product with n, make sure that you have at most 2 variables only. Okay, if you have z extra here, then substitute with the formula. Okay, that's all for today. Thank you guys.